My research focuses on understanding the biochemical interactions of environmentally relevant toxicants, such as microplastics and metals, and the critical physiological mechanisms involved in their toxicity and associated health risks. In my lab, we study these mechanisms and conduct biomedical and environmental studies that could lead to effective solutions that reduce the impact of these contaminants. The Women in STEM award concentrates on understanding the role of polymer fiber exposure in respiratory inflammation and allergic asthma. Microplastics have emerged as a likely threat to the health and the environment. In our initial paper published in Toxicological Science, we highlighted how factors like dose, size, photoaging, essentially the surface weathering and the chemical properties of the particles, how they can significantly affect the toxicological response of a human airway epithelial cells to polymer plastics. These findings increased my curiosity in exploring the impact of polymer plastics that are relevant to the environment, such as polyester fibers, which are known to constitute over 90% of indoor dust. To start the study, we used 100% flame-retardant microfiber polyester baby cloth. We developed a protocol to collect the fibers and leachate for characterization and exposure studies. Some interesting findings are the detection of submicron fiber with a respirable diameter of less than 90 nanometer and the leaching of numerous mutagenic and carcinogenic organic compounds. The characterized fiber leachate were then used to evaluate the allergic inflammation in response to intranasal exposure to polymer fibers by studying an asthmatic house dust mite in vivo model. We focused on nasal exposure because human nasal cavity was reported to represent a potential deposition site for microplastics, including polymer fibers. The Advanced Women in STEM Award allowed the initiation of my collaboration with Julie Ledford Laboratory at the University of Arizona, which has strong history of expertise in pulmonary infections and asthma. Through this collaboration, I was able to get out of my comfort zone as a biochemist and toxicologist and build new expertise in asthma models. The findings of this project importantly reveal alteration pathways in Th2 immune response in allergic eosinophilic inflammation. The topic of the impact of polymer plastics on human health is of tremendous importance currently. We are talking about polymers that are very much involved, integrated in our daily lives and practices, and yet we know a little about their health impact. My lab will continue working on studies that are designed to produce valuable insights into the toxicity of environmentally relevant plastics to create effective future intervention strategies for plastic exposure.